The objective of this lesson is to draw an open area model to represent a 2-digit by 2-digit multiplication problem. Prior to this lesson, students have practiced representing multiplication of 2 digits by 2 digits by graphing arrays and open area models on graph paper to represent partial products. An open area model is a rectangle divided into each place value. In this lesson, the open area model is not proportional, so graph paper is not needed. We will use an open area model to represent the approximate size of each partial product. This lesson will help students move from the concrete model, visualizing how a multiplication problem is decomposed into its separate parts. The term partial product means part of the answer to a multiplication problem. Partial products are added together to get the complete answer. Another term used in this lesson is decompose. Students break a number apart into expanded form. The number 372 is really 300 plus 70 plus 2. Let's try solving a problem by drawing an open area model. The 67 nurses on staff at the hospital have each worked 34 hours this week. How many hours must the hospital pay in salaries this week? First, decompose both numbers into tens and ones. The 67 is 60 and 7 ones. The 34 is 30 and 4 ones. Draw a rectangle that is a little wider than it is long. In other words, the rectangle should represent more rows than columns, since it is a model of 67 rows times 34 columns. Write the decomposed numbers along the left and top of the rectangle. On the left side, write a 60 and a 7. On the top of the rectangle, write the 30 and 4. Then draw a vertical line a little past the midpoint and a horizontal line a little closer to the bottom of the rectangle. This creates the 4 sections of the rectangle that will correspond with the 4 partial products in the multiplication problem. Multiply the width and length of the upper left section. 60 times 30 equals 1,800. Write the equation in the box. Then multiply the dimensions of the upper right section, which is 60 times 4 equals 240. Write the equation in the corresponding box. Next, multiply 7 times 30 and write the equation 7 times 30 equals 210 in the lower left box. Finally, multiply the 7 times 4 equals 28 for the total product in the last box. Each partial product is the number of squares that each section would represent if graph paper were used. The partial products are added for the total product. Students should check their work using the distributive property. First, write 67 times 34 horizontally. Then decompose 67 into 60 plus 7 and 34 into 30 plus 4, and put those in parentheses. Now multiply everything in the first parentheses times everything in the second parentheses. 60 times 30 plus 60 times 4 plus 7 times 30 plus 7 times 4. And you will get the partial products of 1,800, 240, 210, and 28. And when you add the partial products, 1,800 plus 240 plus 210 plus 28, you get the product 2,278 as the answer to 67 times 34. As students transition to more efficient methods of multiplication, they will recognize the same partial products and be able to keep a mental check of their accuracy. The objective of this lesson was to draw an open area model to represent a 2-digit by 2-digit multiplication problem. We met this objective by drawing an open area model to represent the partial products that are added together to get the total product.